Rufio! I was talking about the benefits.
And it's really good to be here in England. Been here for more than a month. We're back. So a bunch of us, we went on this journey where it all started with this new ISP that just popped out in Malaysia, and they were one of the first 4G providers in Malaysia.
In the world.
In the world, so they say. And luckily, we managed to get invites to the launching party, and we managed to get free stuff like a dongle and a MiFi device for free. So once we got it, we didn't actually stay for the event, so fuck that. We went down to the bar and we tore everything open and started playing with it. So I think it was about roughly around 15 minutes.
That's a big time, baby.
About 10 minutes, we managed to get free internet. And we realized that they were using a captive portal thing, but it only redirects HTTP traffic. So we only realized it when our Skype was suddenly online and we tried to tunnel everything out and it just worked. So free internet. And after that, it kind of went bad for them because everyone was trying to use the service, but it was down, no one could register the website and everything. And they were blaming hackers for it. For some reason we got blamed for it. And so, okay, never mind. So the next day we got together and still played around with the whole internet and the device until we got a call from them asking us if we could drop by their secret security center to help them with a problem. So they had two problems. One was the free internet, which we found. So they wanted us to tell them, explain to them how we did it, which we did. And later on they told us they're also under a DDoS attack and that no one could access the website. So we helped them figure it out for free. And yeah, it's a community service. So,
They didn't even give us fucking free internet after that, man.
Yeah. So we did them a favor. We never told anyone what actually happened. So what actually happened was we realized that there was this specific host in their internal network which was sending packets to their web servers, right? And we also realized the settings in their Apache config was, I think it was TTL set to 900.
Yeah, like keep alive.
Yeah, the keep alive was set to 900.
Oops.
And because of that particular machine was infected with malware, it kept going to that server and bringing everything down, so no one else could access it.
They lost themselves.
So yeah, so they lost themselves. So anyway, after that we played with the devices some more, and we managed to jailbreak them and found a bunch of zero-day vulnerabilities. Well, no, they're not 0 days anymore, but we managed to find some cool stuff and managed to figure out what you could do with those cool stuff, which is what this talk will be about. So, yeah, welcome to Hackager Random 600 another data box. I think I got that right. So this is when I presented APL, it was the two of us. It was me and Biacho. So some quick stuff about me. I'm the dude who used to run HITB CTF. I've been doing it since 2008 until this year. This year was my last. I work as a pen tester for a big firm, and when I'm not working, I usually tinker. Twitter account. And some stuff on Biacho. He's the dude who takes the pictures.
Not today.
So we also had another friend who really helped us a lot in this little project, and he doesn't really want to be known, but so we'll just call him a random brown panda. So some basic stuff on 4G is based on all IP packet switch. Peak data rate is about 100 megs high for mobility, approximately 1 gig for local wireless access, dynamically share, scalable channel bandwidth, peak link spectrum, and everything else. This was the initial specs for 4G, and after that it was agreed that LTE and WiMAX is also 4G. So this is the device that we've been playing with, we call it the huddle, which is what the ISP calls it. So it's called the S4G huddle. But initially it was by this company called Infomark, a Korean-based company, and they developed it. So it's an IMWC610W. It's a portable WiMAX to Wi-Fi router, fully compatible WiMAX. Allows Wi-Fi devices up to 4, but you could actually hack it, and we've tried until 9 before 10 kind of dies. It supports USB tethering, and it's ARM-based, and it also runs Linux. So initially someone else did find bugs on the same hardware, so it was for the Clear IE Spot, same device. So the vulnerability was the CVE 2010-4507. It was discovered by Matthew Jakubowski, or Jaku, from Trustwave Spider Labs. And his attacks were more to CSRF. And we tried the vulnerabilities that he found, and we realized that only 2 of them worked, which was to enable Telnet and also to download files off the device. Everything else didn't work. And this is his proof of concept for enabling Telnet. And this is how we got files off the device. So we managed to get Telnet, but we couldn't log in because we don't have the root password and we can't reset it. And none of the other vulnerabilities work. So what we did next was we started downloading all the common files we could find on Linux, especially embedded devices. And we started doing some analysis on it, especially the CGIs, which handles the authorization and stuff like that. And later on, about a day or 2, I think, we managed to jailbreak it. So we came up with the first exploit, or POC, which is, I think it was a command injection through the NTP settings. So what we did was we injected password-e, which removes the root password, and we telnet into it as root. So a few other bugs that we found was command injection in the DMZ settings, command injection in the port forwarding settings, and the remote management settings. So I think we had about 5 bugs. This is the tree, and the other one was the NTP. There's also another one where we think you could inject by appending the command to a file. But the thing is, it's a firmware upgrade function. So none of us were willing enough to test it because it might break. And the device is fucking expensive. It's like 400 ringgit, which is about 100 euros. So fuck that. So this is the vulnerability for the DMZ settings. Basically, you just inject your commands to the host IP parameter. So what this does is it injects a string to a file called XYZ in the temp directory. And this is how I quickly did it. We're using verb. And that is the result. So the same goes for the other 2. This one requires injection to the add host IP address. Verb, and there you go. And third one is injection at the remote access port parameter. So what's cool is, being an embedded device, it runs as root, so you have total control over it. So after we found vulnerabilities, we were thinking what else we could do with it. And since now we have root, what if we could roll out our own custom firmware? So you could pretty much configure it the way you like it. It doesn't have to be wireless maximum at 4. You could set it to 9 or 10, stuff like that. So it was a bit tricky at first because we realized that if you jailbreak the device, the ISP would silently push firmware upgrade, and it'll reset everything, and you kind of lose your jailbreak capabilities. So what we did was, the first thing we did was disable the over-the-air firmware update feature, and there are there's this one file called upgrade.config where you have to either delete or alter the auto upgrade URL or auto upgrade URL ext1 parameter to something else. So I just set it to fuck you and it did it.
Were you able to download the image by yourself?
Yeah, you could.
And do reverse engineering on it?
Yeah. So this is the firmware that we were working on. But there was actually two versions of firmware that we had. One was from the Clear iSpot, which is still hackable, and this is the firmware that we had, which kind of had some changes to the firmware, but we'll get to that later on. What I did to reverse the firmware was found this really cool tool from OZ Paul B, which is called Firmware Tool, and it is specifically for this specific firmware. So it extracts everything out. So when it extracts two files, the firmware info.txt, the kernel file, and root.fs, and the Wi-Fi firmware. So this is the steps to extract the firmware out. See, you run the firmware tool, and then what you have to do is you have to convert it because it's a JFFS image, and it's in I think it's in Little Indian. So you have to convert it to Big Indian in order to work it, and you have to also insert the necessary modules for JFFS and block characters and stuff like that. And then we ran into problems. So initially I was talking about how there was two versions of firmware. So we noticed by comparing the two firmware, we noticed that the firmware we had, there was an extra, I think there was 64 bytes of data at the end. So what sucks about that is we managed to customize the other firmware which didn't have the 64 bytes. And you could just flash it and it worked. But with the new one, we realized that even if you flash it, it won't actually accept the firmware because we think it's part of a signature. So we did some testing and we realized that out of the 64, only 40 bytes matter. If you change the others, you can still load the firmware, no problem, but it's only those 40 bytes. So far we haven't actually managed to figure out what they are. And that's the problem because the Flash program will not allow flashing of older software, older firmware. So if you had firmware 2.0 on the device, you can flash it to 1.5. It also keeps track of the firmwares in a table full of MD5 checksums. It also refers to a file called version.svn, and also the 64 bytes. So initially you could tamper with all the first three without any problems, but with our firmware we had the 64 bytes, which even if you do tamper with it, it won't upload, it won't accept the firmware. So which is where we are stuck now. So using what we have right now, we realized you could pull off really a bunch of cool stuff with it. Like for example, if you combine the 0 day with CSRF and some social engineering, you could do a lot of things. A few other stuff you could do is steal accounts, which we've done. No, I mean for testing, seriously. Not myself. So you could theoretically start a botnet using it, though I'm not sure if 20,000 devices is big, but interestingly, you could also access the client's machine. So if you had 4 people connected to the device, you could launch an attack remotely from the internet to their machine by combining the 0 day with some scripting. Cool thing is you could redirect traffic, which is we didn't test for it, but in theory it should work, and that has to be some other cool stuff too. So for hijacking accounts, we came up with this theory, like what if someone send you a link and you click on it and you don't realize it, but your device gets prone. So we did a POC where I wrote a PHP script which actually executes the 0 day and masquerades it as a PNG. And if you look at the code, the exploit is there. If you look where I'm actually downloading a shell script to the device, and then jailbreaking it, and then stealing the account. And this is what I get in my cookie jar, or my account jar. So yeah, Gacho's account, no one else's. This is the script that the device downloads. So basically the payload in the HTML tells the device to download this script right here, and this script will execute and does all that. So what I did was grab for the password, and identity is actually the username, then pass it back as a GET request to my server. Next thing is how we could attack people behind the device. So this is this Nmap scan is what it looks like before you actually launch the exploit. So this is the results from the device itself. And then you do this again. So this is actually quite simple, because what I did was I just set the DMZ setting to yes and pointed it to an IP. So another test that I did was how to dynamically find the correct IP address, because by doing this you have to initially know the IP address of the target. So what you could do is you could inject in the same way as how I stole accounts. You could get it to download a shell script which actually checks the ARP table and then finds the IP from there. And this is the Nmap scan after the payload. So you could see that you could totally see the Windows machine. So I have a video demo if you guys want to see it. It's basically how you could hijack someone's bank account using the 0 days.
Sure.
So initially when I showed this video in KL, I had to kind of censor it, but I guess I'm gonna have to do so here. Oh wait. Oh, okay. I got the wrong video. Sorry. Shit, where did I put it? Ah, here it is. Yeah. Sorry, it's not my laptop.
Good excuse.
Thanks.
Not you, though.
I like the naming of the slides. I need the not to second the box, but just like
Okay.
candy.
So what I tried to do was to change the DNS records on the device itself. So what if you could point, we have an online banking website called maybank2u.com.my. So what if you could point Maybank to you to your own server, and you have a big login page and everything, simulate as many things as enough to steal accounts and not get busted for it. So so the user does know. So that is initially the IP addresses of the DNS servers that's on the device. So this is the original IP address of maybank2u.com.my. So this is the actual maybank2u.com.my. To be honest, it looks kind of sucky because like all the graphics are like it's not properly there. They had this promotion going on, free tickets.
Robots to throw inside me.
I'm really thinking hacked by God. That's
So just to prove that you can actually do this without being authenticated to the device. Then we go to the payload. if you check out the DNS IP address, it's been changed to a different server. So this was the original IP address, so what I did was I changed the primary DNS to my own. And the secondary DNS remains the same. So I'm going to forward this a bit. So here I'm going to show that when you ping Maybank to you, it's actually a different IP address now, which is the server that belongs to you. But, it took a while for the DNS to actually resolve, so let's come.
Watch the image.
Yeah. So
There you
you
go.
realize that it's a different IP address. So initially the IP address of Maybank to you was 202.168.17.68, and then through the exploit we managed to change it to something else. And if we actually go to the Maybank website, we actually see a Maybank login page. Just pretty much the same, except it looks better, you see. So, just to prove that this is a fake Maybank account, Maybank website, so what I did was quickly paste a text file saying that this is fake. So, yep.
Got your bank account.
Yeah.
Soon.
So yeah, that's like one of the stuff you can do with the series. So we got us thinking of like how you could do this in real world, like what would happen here, how easy would it be to actually exploit this. So we did a little experiment, borderline legal, but yeah, we were really curious to know like, what would come up and stuff like that. So here's the story of the girl. Her name is Riz Latif. I think she's kind of okay, pretty and stuff like that. So we created a fake Twitter account. We created the persona and everything, and populated the account so it doesn't really look fake. And then we started to interact with the ISP. So I tweeted to them saying that if there is a binding contract if I subscribe to your service, right? So after a few minutes, they replied saying, thanks for the interest. There are no contact. What? Yeah, I hope there aren't any contact. I bet that's what he was thinking, the guy who replied it. Yeah, there'll be contact. But yeah, no contract involved when you sign up for Just4G, and gave me a link for more information. So I replied, and I told them, cool, thinking of getting Just4G tomorrow. And I actually did it. I waited for like 3 more days. It's pretty hard to get. So they said thank you for supporting us, stuff like that. So I think about 5 days later, I tweeted that I bought the device finally, and I did a speed test, and this link here is my results. So if you get the best purchase ever this year, you should get it. I tweeted it. And they retweeted it. So the other funny thing is, you see that retweet by Wingdot guy. I think is he? I'm not sure, but we think he might be like a top guy in
He
the
is one of the top guys, but he's not the CSO.
Yeah, he's a top guy. So that's kind of funny. So we know that if you were actually to do this, it would definitely work then.
It really does.
Child's play. So after that, we kind of stopped working on it. But I saw this. I was reading this article on this website someone tweeted, and he was talking about the Pineapple Wi-Fi, which I think is a really cool device. It's like a mobile road AP where it's battery operated. You can just bring it around, and I wanted it, but it was kind of expensive, and you have to ship to Malaysia and everything, and they were also out of it. So it got me thinking, you know, like what if I could use the same device, the Huddle, and turn it into somewhat the same as a Pineapple Wi-Fi, except with less functionality, but just enough to do what I want it to do, which is to fish for accounts.
Jeez.
So I actually managed to do it, and surprisingly, it was very, very easy. And it's cool because it's smaller than the Pineapple Wi-Fi. It fits in your pocket, and I think the battery lasts for like 5 hours. And so you could you technically have a Rogue AP in your pocket. You could just be walking around, someone would use it, go to Facebook or whatever, go to your fake login website, and then pop, you get an account. So what I did was I think I created 3 fake logins, which was Gmail, PayPal, and Facebook, and I placed the pages inside the device itself, so it doesn't need internet. And I used 3 things, which was DNS mask to do DNS stuff, THTPD, which is the web server, and a CGI script to actually save the credentials. So this is supposedly Facebook account, but if you ping it, it's actually the device. So as long as your laptop or your phone or whatever, as long as your network settings is default, meaning it will use the device's DNS settings. So it will print Facebook or whatever website you do to the device. And this is actually the fake login page on the device itself. And this is the CGI script that I use, which is just a few lines, it's freaking simple. It saves the credentials to a text file on the device itself. And this is a test that I did to show that it could, capture accounts. So, hang on. So, yeah, this is like one of the cool stuff you could do. And there was also this other test that I wanted to do, but I didn't really come to doing it. Is what if you could reroute traffic from the device to an external server, pass it through, sniff it first and then pass it back, and that would be kind of cool, So I've taken the time to draw this very sophisticated. So this is how a standard connection would be if you were to serve the internet. So it goes to the internet and then to Facebook, Gmail, or Twitter. That looks like a bird, right? Okay. And so what if you could redirect it to your own server? So instead of going straight to the website, if you combine, it's a mobile device, it's a network device. It has IP tables on it. You could do a lot of stuff with it. So you could redirect traffic to your own server, sniff it, and then pass it to the website, and then pass it back. Do a man-in-the-middle attack, but on the internet. That would be really cool, right? So this is one of the stuff that I do want to do, but I haven't actually come to doing it yet. But I'll do it, and I'll let you guys know if it works. So I think that's pretty much it. Do you guys have any questions or stuff? No?
No question?
Where's the CD?
Yeah. This is from GL. I did my slides at all. But I work really hard on the diagram. So thank you.